Welcome back everyone. In this video we're going to learn about coordinate geometry. Now before we dive into the complicated formulas and the numerical problems related to them, let's understand about their origin. The origin of coordinate geometry can be traced way back to 290s. During this period it was mainly used by Indians and Greeks. It is to be noted that this coordinate geometry was without algebra. Then in 1596, almost 1300 years later, algebra was introduced to coordinate geometry. Let's dive into the usage. To understand this, let's consider an example. Say that this is a set of 25 rooms and you have to indicate someone to go to this room. Obviously you can say go to the room T, but what if you don't know the names of any of the rooms? In this case, you have two options. First of all, you can say go to that room by pointing a finger to that room. Or you can say go to that room in the 4th row and the 5th column, or 5th column, 4th row. So, which is better? Now, in the first case, it's very confusing to which room you're pointing. So it'll be very difficult to exactly know where to go. Whereas in the other case, it's very easy to follow up. So 4th row, you can go to the 4th row, that is 1st, 2nd, 3rd, 4th row, and 5th column. So 1st, 2nd, 3rd, 4th, 5th column. So it is definite that you'll have to go to room T. On the other hand, it can be also described with 5th column and 4th row. So 1st, 2nd, 3rd, 4th, 5th column, and 1st, 2nd, 3rd, 4th row. So 5th column, 4th row exactly pinpoints to room T. Let us also see some real life examples where coordinate geometry is used. Coordinate geometry is used in GPS to pinpoint your exact location or pinpoint the exact location of your destination. For example, it is used in Google Maps. It is also used in astrophysics to pinpoint the exact location of a planet or a black hole, and etc. Now, in coordinate geometry, the plane is divided into 4 parts by 2 axes known as x-axis and y-axis. X-axis is also known as abscissa, y-axis is also known as coordinate. Now, these axes divide the plane into 4 parts: quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Along the abscissa, if you move from the center towards the right, it is taken to be positive, whereas towards the left it is taken to be negative. Similarly, along coordinate or y-axis, from the center towards up it is taken plus y, and towards the bottom it's taken to be minus y. Now let's dive into the first formula, that is distance formula. Now the formula to find the distance between 2 points, let's say x1, y1 and x2, y2, is square root over x2 minus x1 whole thing square plus y2 minus y1 whole thing square. That is square root of difference of abscissa squared plus difference of ordinates squared. Let us discuss a special case here, that is distance from the origin. We all know origin is 0, 0, that is x coordinate is 0 and y coordinate is 0. So if you substitute 0, 0 here, we will get this kind of formula: x minus 0 and y minus 0. X minus 0 is x whole thing square, so x square. Y minus 0 is y whole thing squared, so y square. So the new formula for this special case will be d is equal to square root over x square plus y square. Note, we did not write x1 or x2 or y1 or y2 because we do not have 2x or 2y. Let us look at this chart. Now here we will revise the properties of square, rhombus, rectangle, parallelogram but not a rectangle, rhombus but not a square. So if we recollect, the properties of squares are all four sides are equal, both diagonals are equal. So for a rhombus, all four sides are equal. That's the only property of a rhombus. The diagonals are not equal. For a rectangle, opposite sides are equal and both diagonals are equal. For a parallelogram, opposite sides are equal, the diagonals are not equal. So parallelogram but not a rectangle. To show that, you'll have to show that the diagonals are not equal. Rhombus but not a square. You'll have to show that the diagonals are not equal. So let's understand this with an example. Let's say we found the four sides of a figure to be equal. Now we have to understand this, that we cannot blindly say that it's definitely a square, because if four sides are equal, it may be very well a square or it may be a rhombus. But in order to differentiate between square and rhombus, we have diagonals. Now only in the case of square we have the diagonals to be equal. So we can also find the diagonals. Once we have found the diagonals, if the diagonals are equal, they're definitely a square, and if they are not equal, then they are definitely a rhombus. Similarly, for two opposite sides to be equal, we cannot directly jump to the conclusion that it's definitely a rectangle, because it may very well be a parallelogram. So in order to take the decision, we'll have to find the diagonals. If the diagonals are equal, then we can for sure say that it is a rectangle. And if the diagonals are not equal, then we can for sure say that it is a parallelogram. Thank you. I hope to see you in my next video. Take care, everyone.